All right, question 11 from the practice exam, right? When a metal and non-metal react, the blank tends to lose electrons, right? So when a metal and a non-metal react, remember all of our cations, our metals tend to react and form cations, right? And they form a cation by losing electrons. So our metal tends to lose electrons, and then our non-metals over here, those what form the anions. I shouldn't have circled the noble gases because they don't react, but right, our non-metals, they want to gain electrons, right? So for our metals, something like sodium is our cation. Our non-metal, something like chlorine, reacts, gains an electron, becomes chloride. So our non-metal, after they react, what type of bond is formed, right? And so our choices, I made it pretty easy for you. You had 4 choices for 3, blanks. And when a metal and a non-metal react, right, we're going to get an ionic bond to form. The one challenge with this question is you have to use the text that is provided. So if you said metals, or you put a space in non-metal or non-metals, it'll flag that, but it should be okay other than that. But in the case of hydrogen in a reaction, it is not a noble gas. Correct. Hydrogen can react both ways. It can lose an electron, becoming a cation, and it can also gain an electron, become hydride as well. So hydrogen is a little bit unique in that way. All right, question 12. Pair of elements most likely to exhibit similar properties would be, and again, for question 12, we need our handy periodic table of the elements, which I'm sure everybody has saved in their clip art. All right. Okay, right. The elements that are going to have similar reactivity are going to be in the same group. Remember in class, we watched a video of lithium, sodium, potassium, and cesium reacting. They were all water reactive. They gave off hydrogen gas. Some of them exploded, caught on fire, right? So we look at this. Sodium and calcium, different groups. Can't be that. Sodium and magnesium, different groups. Can't be that. Potassium and argon, again, different groups. Can't be that. So we can erase all of those so far because they're all different groups. Gold and palladium, right? Here's gold, here's palladium. Again, they're different groups. Can't be that, but gold and copper, right? Here's copper. They're both coinage metals. So gold and copper are going to have similar reactivity, right? Gold, silver, and copper actually will all have similar reactivity because they're in the same group of the periodic table. Yeah, can we also put the questions so that everybody can see them? Because I think, so like Sarah just asked a good question that I think everyone would want to know the answer to. So Sarah asked, should we know the other trends on the periodic table other than reactivity? And the main trend that we talked about, the main trends we talked about on the periodic table that everybody should know is when they react, what ions they want to form, right? We talked about group 1 metals want to form 1+ cations. Group 2 want to form 2+ cations. Aluminum be over here on its own, 3+, nitride, phosphide, 3-, oxide, sulfide, selenide, 2-, fluoride, chloride, bromide, iodide, -1. So for right now, Sarah, that's kind of what we should know. Is we'll get into more periodic trends later, like ionization energy, electron affinity, atomic radii, ionic radii. But for right now, the big thing is to kind of know like what the general charges should be for some of those groups. Within the transition metals, right, it gets a little bit complicated. Yeah, only really aluminum we have to worry about in this case. Boron, carbon, They're kind of like in between. Carbon doesn't really want to lose electrons, doesn't really want to gain electrons either. Yeah, I just answered that, Kevin. Yeah, like, so these are really good, right? Semiconductors. And it's because of they don't really want to gain electrons, they don't want to really lose electrons. And so that's where we find these unique properties kind of like in this balance between metals and non-metals. So silicon, right, we're using it right now in our computer chips. But a lot of the other semiconductors, we use germanium, arsenic, like gallium phosphide, nitride. So those metals that are right in between, those metalloids, they kind of have, we can't say because they kind of react uniquely. They just demonstrate distinct reactivity, I should say, compared to the other metals. There was one other question. Can you go over a breakdown of how many questions for the calculation? Yeah, maybe towards the end. All right. Question 14 is up next, and then 15, and then I'll break this video off. Yeah, correct. Right, those charges on the periodic table are going to help us when we have to figure out how things come together and form a neutral compound in terms of naming ionic compounds or molecular compounds or with transition metal compounds. Yeah, those charges are going to be essential from the periodic table. Question 14, the pair of elements most likely to form a molecular compound, right? A molecular compound is crap, I did it again. Not what I wanted. A molecular compound, right, is a non-metal with non-metal. So can't be a metal, right? Can't be that. Let's see, barium is over here, so it can't be that. Potassium, sodium, again, they're over here, can't be that. Sodium and sulfur, right, that would be ionic, so it can't be that. So it must be on our next page, right? We're looking for a molecular compound. So yeah, a molecular compound, right? Non-metal with non-metal. So a molecular compound would be with choice E here, carbon and oxygen, right? Non-metal with non-metal. So carbon monoxide is a molecular compound. Carbon dioxide is a molecular compound. Yeah, so question 14, the choice would be E, all right? And then, yeah, I'll answer that after I finish this question, right? All atoms of a given element have the same number, right? Mass can vary because our number of neutrons can vary, right? Those are isotopes. Number of electrons can certainly vary because we have ions that can form through loss of an electron or gain of electron. Have no idea about density, right? But what makes that element is the number of protons, right? Our atomic number for carbon is 6, right? Carbon has 6 protons. Our atomic number for nitrogen is 7. Nitrogen has 7 protons. I can't change that number or it changes the element. So question 15, the choice is A. All right, and then Sarah asked another question in the chat. Let's see if I can do this correctly this time. Yeah, right. Oops, here we go. I think we did have some, maybe not, but the transition metals, right? All the metals can have positive charge. The transition metals are where the charge can vary, and we're going to get that. We're going to figure that out, right? There's no way to memorize it, right? But we can figure out the charge on a transition metal based on what it's bonded to. So an example would be like FeCl3, right? Iron's a transition metal, can be +2, can be +3. We don't know. But we do know if we break this up, All right, I've got 1 iron, I've got 3 chlorides. We know chloride being a halogen is -1, always. So 3 chlorides, -1 each, a charge of -3. The whole thing has to be neutral. The whole thing has to be 0. So that means the charge from iron needs to be 3+. So this would be iron, Roman numeral 3, chloride. All right, so Sarah, yeah, that's the only way we're going to figure out the charge on a transition metal is by looking at what else it's bonded to and knowing that charge. So we're going to always have to work backwards to figure out the charge on the transition metal. And then with the transition metals, right, we need the Roman numeral to indicate I have iron 3 in this case and not iron 2. Yep. All right, we'll stop the video here.